In this video, let's continue our discussion on classes in Python. In particular, let's start talking about inheritance in Python. So we've previously discussed how to create classes. We've previously discussed the init method, the init method. We've previously discussed self. We've previously discussed creating methods in a Python class. So if you haven't watched those videos or those concepts are not familiar to you, you should probably review that content, review those videos. So now if we're starting to talk about how we can use inheritance and how we can, build a class hierarchy. And let's look at some example code here. So we had previously an SSH function that used Paramiko to establish a network connection to a device. So now I've restructured this a bit to make this be under a class. So we have an init class that contains the host, the username, and the password. So in init, we just bind these three variables to the object: the host, the username, and the password. We then have an open method which actually establishes the SSH connection to the device. Notice at the end of this that I actually create this self.remoteCon, which is actually the Paramiko SSH connection to the device. This remoteCon pre is something you also have to save to the object, or else you get into a garbage collection problem where it'll actually garbage collect this remoteCon pre and will destroy the connection. And that's just something I learned across time from Paramiko's behavior that I learned. I also had to save that to the object. So we bind two things to the object in the open method. So we have an open method, it has self, we have this Paramiko glue code in here that establishes the SSH connection. In fact, it establishes it here on line 16. We then save these two variables, remoteCon pre and this output of invoke shell. We save these two attributes, remoteCon pre and remoteCon, they get bound to the object. So at the end of that, at the end of the open call, we have an SSH connection to the remote device. And then I made two other methods. One that sends data down the channel, so uses self.remoteCon, and Paramiko has a send method, so it's going to send the data down the channel. And then I built a receive method, specifies a buffer size, reads data that's available, and converts it into Unicode. This is what this decode is doing. On the wire, it's a byte string, so outside of our Python program, when we're reading it in or sending it out, we're going to be dealing with byte strings, but when we get it into our program, it needs to be Unicode, and that's what the decode does. The decode takes it in from what it is on the wire, which is UTF-8, decodes it into Unicode. And I always used to have problems with, thinking the decode encode should be the other way. So you encode it when you're converting it to what it needs to be on the wire, like a particular representation of Unicode, for example, UTF-8. That's how you represent Unicode when it's sent out in a byte stream, or that's one representation of Unicode when it's set out on a byte stream. So you encode it in UTF-8 to be what it needs to be out on the wire or out in a file. And then you do the opposite of that. You're receiving UTF-8, you're receiving some particular format that's out on the wire. You decode whatever that format is and convert it into Unicode. I know that's a bit confusing because I always sort of think that those should be the opposite, but I do think it helps me to think of encoding it to a particular representation on the wire, i.e. UTF-8. So all this is doing here is basically receiving data from the remote SSH device. Now, this code is all a bit simplistic. Like, for example, in the receive, we're only doing a single read of a maximum number of bytes. Really, you should have a for loop that reads all the available data. So this is definitely a simplistic, both a send and receive, but it's going to do for work for what we need to illustrate this example reference code. Okay, and let's not worry about that Cisco IOS XE device at this point. Now, if I go down to my main section now here, I'm just using a Python technique that lets me divide importable code, which is above this line, from executable code, which is below this line. This is pretty easy to look up on Google. So if you look up the _name technique in Python, you should get good explanations of what's going on here. But the bottom line is things that are importable, like functions and classes, should be above this line, and your particular executable code for this program should be below this line. This lets you have things that you could reuse in different programs and still be importable in Python without executing this executable code that's down below line 47. So if we wanted to use those classes in different programs, we could, and we would avoid executing this code down here, which we're using in a different program we wouldn't want to be executed. Okay, so what do I do with this executable code? I just import IPDB, I get my password, I create a device instance of this network device. I'm going to establish the SSH connection. I'm going to actually comment line 54 out. We're not going to be doing that yet. Okay. And then I'm just going to send an inner sleep, because our program will go faster than the networking device. Sleep for a small amount of time, half a second, and receive whatever's there. So let's go ahead and execute that. Verify that our SSH connection to this Cisco IOS XE device is working correctly. Now, don't worry too much about the mechanics of PDB here. I'm just using it to illustrate points. I do have an article on PDB, and there's good resources on PDB, and it's pretty simple and pretty straightforward. But don't worry about the mechanics of PDB too much right now. I'm just using it to illustrate this reference code. So let's jump to the end. Let's see what we get back. So at this point, we should have the router's prompt if that all worked correctly. Okay, so we see the router prompt is coming back to us. Now, what if we wanted to use this router1.send and send some sort of command? So before we just hit enter, one or two times. Here, what if we actually sent some command? So we'll send router1.showVersion. So we'll go ahead and send that. Okay, so we sent that down the channel. Now let's do out equals and read whatever we get back from that. So let's see what we get back from reading that. Go ahead and print this out. Okay, so first thing I forgot to do, which is going to be a problem, is I forgot actually to send an enter key at the end of this. So all that we got at this point is just our command echo. It actually didn't hit enter on that command, so it actually never submitted it to the device. So we'll go ahead and hit enter on the command, and now we'll go ahead and read whatever is available to us. Okay, and we'll print that out again. Now we see that we're starting to get the top of show version. Okay, that's great. We're getting our show version output, and we have it, but we see we get to a point here where we start to see the output paging for the device. And we could do things like send enters down to page through all the output. We could, hit a Q to quit out of this, and then we could send terminal length 0. But we know this is a problem that we're going to run into all the time. So we're going to want to think about, well, how could we fix this problem in our code? So how could we modify our code to fix what we're running into here? So the first thing we could do is potentially build a setup method, and we could build something like this, and we could put this as a method inside our main class, and we could basically set a few things. So we could set the terminal length to disable paging, and maybe we want to set the terminal width too. You can start to run into issues with screen scraping. If your command output gets too long, the device thinks it needs to make it more human readable. So it actually starts to distort the output from an automation perspective. It makes it better for human readability, but when we're doing automation, it actually does a lot of odd things by thinking it's making it more human readable, like putting backspaces in the output, trying to line wrap and adjust at certain places. So we're going to just basically tell it, hey, the terminal width is very wide. We want to try to avoid running into this automatic adjustment. We want to try to avoid running into this, having the output being made more human readable due to the line lengths, the command lengths getting too long. Now, if we put this in the base class, this would work just fine for Cisco iOS. So we've put this inside the network device class, and that would work just fine. You know, it would turn this off. We would be able to run our show version. But the problem we would run into is, what about the next type of device we wanted to build this for that was not Cisco iOS and did not use these two commands? Well, then we'd have a problem. So one solution to this problem is we can start to think of using inheritance. So we can start to say, well, this is my base class, my network device class, and it has all these things I've shown here. It has like _init, it has an open method, it has a send method, it has a receive method. Now, I want a setup method that doesn't reside in the network device class. Instead, it resides in a child class. And whenever we use methods in the child class, it'll first look in the child class to say, like, say we created an instance of this Cisco iOS XE class. We created an object of that, and we called the setup method. It's first going to look directly in that class and see, does it have a setup method? Yes or no. If it finds it, it's going to use the one directly in that child class, directly in that Cisco iOS XE class. If setup doesn't exist here, then it's going to look in its parent class. And Python has something called method resolution order, MRO, where it basically traverses the class hierarchy looking for a given method. So we know when we have this code here, we know when we create an instance of this class, the Cisco iOS XE class, we know that one of the first things that happens is the init happens. Now, if you look at Cisco iOS XE class, there is no init defined here. So what happens is Python looks for the _init in the Cisco iOS XE class. It can't find it, so then it looks in the parent network device class, and you can see there is a _init method there. Similar things happen with open, with send, with receive. Now notice the network device class doesn't have any parent defined. There is an implicit parent this way, so it's automatically inheriting from this, pretty generic object bucket in Python, and that's the default, so we don't need to specify it. So there is an automatic inheritance from this Python object container. So the hierarchy in this case for Cisco iOS XE goes from Cisco iOS XE class to network device to that object class. So this allows us to have this specific Cisco iOS XE code, and then all the generic code that could be shared between Cisco iOS XE and Juniper and Cisco ASA and some HP Comware platform, that can all be put into the network device class. So we're starting to build up this hierarchy of classes, and we have this method resolution order where it goes from the class you're working with to its parent, then to its parents, and up however many classes you have in this hierarchy.